Hello, Integrated Math 1. Welcome to lesson 2.3.5. No A or B this time. No day 1, day 2. We're doing it all. We're doing it all. It's actually not that bad. So we're actually not really doing much that's new. We're just applying what we've been using with systems of equations and systems of inequalities. So we're going to be writing them, making them, graphing them, solving them. We're going to be doing all the things with these because you now know all kinds of ways to solve systems of equations. You can graph them, you can substitute, you can use linear combinations, and of course you also are now familiar with solving linear inequalities where we graph them and we look for the regions that overlap, the shaded bits that overlap. So that's what we're going to be playing with. We've got a couple of activities to go through today. It's not that bad. So the BC Bicycle Company, I think that's how you say that, is planning to make a low price, ultralight bicycle. As a cyclist, this makes me happy. There are two different plans being considered for building this bicycle. The first plan, so this is plan 1. In fact, I'm gonna use some colors here, maybe help me out a little bit. So the first plan includes a cost of $125,000 to design and build a prototype bicycle. The combined materials and labor costs for each bike made under the first plan will be $225. So to make the original prototype, all the design, trying to figure all that out, will be $125,000. But once they get it down, then each bike after that's only going to cost $225. The second plan, I better use a different color for this one. I'm going to use a different color. The second plan includes a cost of $100,000 to design and build the prototype, so a little bit less. The combined materials and labor costs for each bike made under the second plan will be $275. So less for the prototype, but more per bike. That's interesting. So you recently got a job at BC Bicycle Company as a financial analyst. So I would like you as a financial analyst to analyze the costs for each proposed bicycle prototype and determine which plan BC should follow. Make sure you provide evidence for your proposal, do the work, all that good stuff. You can't just say, pick that one. If you're a financial analyst, you got to show the numbers and show why that's the better choice. So go ahead and hit pause, do some work here, see what you can figure out, and then hit play when you're ready to check your work. So I'm going to write some equations first. Right? Because we started off with this first plan. Let's take a look at that first plan. So we know for the first plan, it's going to cost me $125,000 right out the gate, right? The design, the planning, the prototype, to build that, it's going to cost that. But once we've got that under our belt, then when we start actually manufacturing bikes to sell, each bike made after that will be $225. So I'm going to do 225 times X. That'll be the number of bikes. So there's plan A, but let's write an equation for plan B, second plan, I should say. Second plan includes a cost of $100,000 to design and build the prototype. So for the second one, we start off at $100,000, which is less. So that's good as a financial analyst. But the combined materials and labor costs for each bike made under the second plan will be $275. So it's actually another, except I can't write it. I say it right. I can't write it right. It's all good. So 275x. So it's going to cost more per bike though. So I now have a system of equations, don't I? Now I rewrote it a little bit. So I had my slope in front and I have my y-intercept at the back. But there's plan A, here's plan B. It's actually first plan, second plan, but you get the idea. So let's solve this. Let's see where they intersect and see if we can use that to help us figure out which one is the better deal. Now, there are a lot of ways you can do this. You can do linear combinations, you can graph it, but I'm going to use substitution. I see that y equals all of this stuff here, which means I can substitute for y. Instead of y, I can plug in 225x plus 125,000. So that's what I did. Oh, look, no more y's. We just have x's. So I'm going to go ahead and subtract 225x from both sides. So that will cancel out, and 275x minus 225x gives me 50x. You guys know what to do now? Yeah, let's subtract 100,000 from both sides. So if I subtract 125,000, subtract out 100,000, that leaves me with 25,000. And of course, divide both sides by 50. Oh my gosh, this is why I have my trusty calculator. Do you have your trusty calculator? I hope so. So 25,000 divided by 50 gave me 500. So it looks to me, if this is where they're intersecting, remember that plan, the first plan was cheaper per bike and the second plan was more expensive per bike. So this is what this says to me. This says that if the company plans to make more than 500 bicycles, then plan A is the way to go, right? Plan A is the way to go. That first plan, if they're making more than 500 bicycles, they're going to get better bang for their buck. But if they're not going to produce that many, if they're going to produce less than 500 bicycles, then plan B is the better way to go because the prototype was so much cheaper. So if the company makes fewer than 500 bicycles, they should use plan B. If they're going to make exactly 500 bicycles, it actually doesn't matter which plan they use. Costs them the same amount. So there we go. I guess it just depends on how many bikes the company is planning on making, right? So let's go to our next activity, 5.2. We're talking about Demetrius. Demetrius is in search of a new cell phone plan, and he's considering 2 different cell phone services from 2 different providers. So Bouncing Cell Service offers a monthly fee of $99.99 and 2,000 megabits of data per month. Now, once a user exceeds the free monthly data allowance, each additional megabit of data used is $0.05, also known as 5 cents. Rolling Cell Service offers a monthly fee of $79.99, which is cheaper, that's cheaper, and 1,500 megabytes of data per month, which is less, so it's fair. Once a user exceeds the free monthly data allowance, each additional megabyte of data used is 8 cents. Ooh, so if you go over, it's going to cost you a little bit more with Rolling Cell Service. Demetrius is unsure which plan to choose. He wasn't very careful with his last contract, and he paid a lot of extra money in charges for data. So he doesn't want that to happen again. So I would like you as a friend, it says to write an email. You're not actually going to write an email. You're just going to write it on your paper here. But advise Demetrius on which plan to choose. And again, provide evidence, right? Don't just be like, man, I like that one. No. Give him the numbers. Back it up. Tell Demetrius which one's the better plan. Let him know the actual numbers, okay? Go ahead, hit pause to work this out, and then hit play when you're ready to check your work. Are you ready? I hope you're ready. I'm ready. I'm ready. All right, so here's the deal. We're going to write a sentence per company. So Bouncing Cell Service, $99.99 per month, and 2,000 megabits of data. So I'm going to write that out. Y equals. So it's going to cost you $99.99 per month. And if you go over your 2,000, then all of a sudden you're paying 5 cents per when you go over. So here's what this is going to look like. I'm going to do 0.05 times, and 2,000 is cool. 2,000 is okay. Hang on, I need to, what? 2,000 is okay. So we're going to say that we're okay unless we go over that. So I'm going to say x minus 2,000. Because if I get to 2,000, I'm okay. It's not going to cost me extra. But if I go over that 2,000, this is not good. So there we go. So there is Bouncing Cell Service. Yay. Let's talk then about our other friends here. Rolling Cell Service offers a monthly fee of $79.99 and $1,500 per month. Of course, if they exceed that, Each additional meg is going to cost them 8 cents. So their equation then is going to look like y equals $79.99 per month plus, it's not 5 cents now, it's going to be 8 cents whenever their time, their allowance, however you want to put it, not time, it's data plan. Whenever their data plan goes over 1,500. Ooh, look at this. We have a system of equations. I have it here on the next page. It's a little prettier there. So here we have it on the next page, our system of equations. And again, don't forget which is which. This first one is our, hang on, I want my pen, my other color. This one is our bouncing cell service. And this one is rolling, right? This is the rolling cell service. Make a little note of that so I can remember which is which. All right then, let's solve. And just like last time, they're both equal to y, right? So everywhere I see a y, I can substitute in, since y equals all of this stuff here, everywhere I see a y, I can substitute in that 99.99 plus 0.05 times t minus 2,000. So I have a long equation. Can we fix this? This is a mess. We need to fix this. I'm going to distribute to get rid of the parentheses. So the 999 stays, and then I'm going to distribute that 0.05, so that becomes 0.05t minus 100, because 0.05 times 2,000 is 100. Equals, I still have my 79.99, but we'll distribute that 0.08. So 0.08t minus 120, because 0.08 times a negative 1,500 is a negative 120. I am going to combine some things a little bit. Let's go ahead and combine our 99.99 minus 100. That leaves me with a penny. Actually, I owe a penny, don't I? 79.99 minus 120 leaves me with negative 40.01. All right. It's still a bit messy. I'm glad I have a calculator handy, but now we can actually work this out. So I'm going to move my t's to the same side. I'm going to go ahead and subtract my 0.05t from my 0.08t, which gives me 0.03t. Still have a negative 0.1, still have the negative 40.01. So let's go ahead and move this guy over as well. Let's add 40.01 to the other side, which means I end up with 40 exactly. How convenient was that? And now I'll divide by 0.03, which wasn't convenient. 40 divided by 0.03 gives me 1,333.3s forever. So what does this mean? Well, if this is where they intersect, here's the deal. Remember that bouncing cell service was less per meg that you went over, and rolling cell service was more per meg that you went over. So here's the deal. If Demetrius is using more than 1,333.33 megabytes of data per month, he should choose bouncing cell service, right? Because they charge less when you go over. But if Demetrius is using less than 1,333.33 megabytes, I should say, of data per month, he should choose the rolling cell service plan. So if he's using less than that, go with these other guys. They have a cheaper starting cost, right? And he wouldn't be going over his minutes anyway, so it'd be okay. So it looks like that's the break-even point. That's good. So Demetrius really needs to analyze how much data is he using each month. If he's using more than this amount, go with bouncing cell service. If he's using less than that amount, then he should choose the rolling cell service plan. Just depends on how much he's using. Now, we've been dealing with linear equations. Let's come back to our linear inequalities. So we're going to solve a system of linear inequalities. Only notice now, instead of 2 inequalities, which we were calling constraints the other day, there's now 4. So Miguel's eye doctor informed him that he needs glasses. Now, luckily, the local vision store is having a sale on all eyeglass frames, and the advertisement in the window is as shown. So here's our lovely advertisement. So we're going to save 60 to 75% on all frames, regularly priced at $120 to $360. It's a mouthful though, right? And so we need to figure out if we can really get a deal on this and what kind of a deal we can get. So previously, you solved a system containing 2 linear inequalities. However, systems can consist of more than 2 linear inequalities. You can have more than 2. Don't worry, we're going to walk you through this step by step, hopefully, so you don't freak out. That's the dream. So I would like you to use the advertisement to write 2 inequalities that represent the regular price of eyeglass frames. And you can use an R to represent regular price. So give me 2 inequalities. Maybe you can even think of it as a compound inequality. I'm just saying it's an option. I'm throwing it out there. Go ahead and hit pause to write your 2 inequalities, and then hit play when you're ready to check your work. Now, I hope you didn't overthink this too much because it wasn't that bad. We're saying, look, R can be between 120 and 360, right? So it's somewhere between these guys, which means R could be greater than or equal to 120, but it could also be less than or equal to 360. So the way I'm going to write this, if you remember our compound inequalities, this is an and statement. Our regular price could be greater than or equal to 120 and less than or equal to 360. So in order to get this deal, this has to be the case, right? That your regular price has to be greater than or equal to 120, and it also needs to be less than or equal to $360. But now I'd like you to use that same advertisement to see if we can write 2 inequalities that represent the sale price, the reduced price. So we're going to let S represent the sale price and the term and the frames in terms of R. So I don't really want hard numbers here. I want some inequalities, and you're going to have an R variable in your inequality. Go ahead and hit pause, see if you can figure out what I'm asking you for there, and then of course hit play when you're ready to keep the discussion going. All right. Keep in mind, all percents are out of 100. So if I save 60%, I'm actually paying 40%, right? And that means that if I save 75%, so if it's 75% off, I'm still paying, I want all my percent signs in there. I'm still paying 25%. Yeah. So when I write my inequalities, the sale price has to be between 25 and 40%, right? So that means the sale price has to be, actually, hang on, let me move my S a little bit. There we go. So the sale price has to be between 40% off of R. Except we don't write percents as that way. We write percents as decimals, right? When we put percents into equations, we have to write them as decimals. So 40% as a decimal is 0.4, and 25% as a decimal is 0.25. So we're saying that our sale price needs to be between 0.25 of the regular price and 0.4 of the regular price. So our sale price is somewhere in between. Look at that. This is an and situation again. Our sale price is going to be greater than or equal to 0.25 of the regular price, and that sale price is going to be less than or equal to 0.4 times the regular price. And lo and behold, people, we have not 2 inequalities, we have 4. I want to just have you check somebody else's work real quick. Heather wrote this system of linear inequalities for the problem situation. Can you explain why it's incorrect, what she did wrong? Go ahead and hit pause, write it down, and then hit play when you're ready to check your work. So I hope you noticed where she went wrong. Her R's were good, right? The R's were good. Our R's look the same. R is greater than or equal to 120. R is less than or equal to 360. We had the same thing too. But look at what she did with her sale price. Oh, so Heather correctly wrote the inequalities for the regular price, but she incorrectly wrote the inequalities for the percent off the regular price. Because remember, we're not paying 60%, we're getting 60% off. We're not paying 75%, we're getting 75% off. So we're actually paying 40% to 25%. So her inequalities mistakenly indicate that the sale price of the eyeglasses is between 25% and 40% off the regular price. So she just got a little backwards. It's an easy mistake to make. Although those of you that are shoppers, I bet you didn't make that mistake. I bet you were like, I know how this works. Some of y'all are shoppers. I get it. It's cool. So now that we have the correct inequalities, and we have the correct inequalities now, we've put them all together as a system. I would like you to graph all of these on the grid. And in fact, it might help. We use S's and R's. Hopefully you're noticing that the regular price R is your x-axis. So maybe I'll turn that into an R. And that our sale price Y is our sale price S is our y-axis. So if you want, you can turn those into R's and S's. It might make it a little bit easier. That's totally fine. So go ahead and graph each of these inequalities on the grid. Don't worry about shading just yet. Go ahead and start by graphing the boundary lines. If you're brave enough to try and shade, go for it, but there's going to be a lot of shading, so it gets shady. Go ahead and hit pause to graph your inequalities, and then hit play when you're ready to check your work. All right, let's graph each of these things, and it's going to be a lot of graphing. So R is greater than or equal to 120. So 120 on the R-axis, there it is. So we're going to put a little dot there, and of course, that means it's just a straight up and down line because I don't have any other variables. And of course, it does say greater than or equal to. Equal to means it's a solid line. Greater than means we're shading to the right. So we're going to shade all of that. This is not my best shading job ever, okay? Let's now take a look at the next one. R is less than or equal to 360. So here's R, here's 360. But of course, I don't have any other variables, so it's just going to go straight through. It is a solid line because of the little half equal sign. R is less than 360. Ooh, less than 360. So hang on, I'm going to use another color. R is less than 360, so I need to shade, I keep losing my, there it is. I need to shade everything to the left of that line. So I'm going to shade everything to the left. That is that's a terrible shading job. Oh my goodness. It doesn't even deserve it. I did a bad job of shading on the yellows. Sorry. I'm going to try and do better. Use another color so I can see it better. So we're shading everything to the left, to the left, to the left, to the left. There we go. Great. S is greater than or equal to 0.25 R. Well, there's no plus anything on the end, so that means it does hit right at the origin. The slope 0.25, there's a lot of ways to think of that slope. You can think of it as 25 over 100, which actually simplifies down to 1 over 4, however you want to do it. But if you go up 25 and over 100, it gives you a dot, and you can connect the dots. Sorry, my dot's down here, but you can connect the dots. It does say that S should be greater than that, so that means we got to shade everything up above. So hang on, let me grab another color, and I'm going to shade everything above that line. So I'm going to shade it all. Again, not my best shading job. Sorry. So I'm going to shade everything above. Woo, that's shady. All right. And last but not least, we do need to do S is less than or equal to 0.4 R. Again, there's nothing being added on the end. So again, it goes to the origin, it goes through 0. Again, we can think of our slope as 4 over 10, since that is 4/10, or 2/5, or however you want to do it, however you want to do it. Or you can even think of it as 40 over 100. That's okay too. So if I go up 40, I need to go over 100 and make sure that our line goes through those points, which it does. Hooray. This says that S has to be less than that though, so I need to shade below. So I'm going to shade below that line. Now, let's be honest, people. I made a big old mess of this graph. Do you see what I mean about the shading, how it got kind of crazy? Do you remember that when we are trying to find the solutions to a system of inequalities, we're looking for where they overlap? So I want to know where all 4 of those shady regions overlapped. Where did all 4 of these overlap? So I would like you to just maybe erase some of the shading that you did and ignore some of my awful shading. I just want you to shade in just the portion of the graph that satisfies the system of linear inequalities. So just shade the bit that's true for all of them, where they all overlap. And once you do that, can you tell me what shape your solution kind of resembles? Go ahead and hit pause, shade it, work it out, and then hit play when you're ready to check your work. All right, so I had to shade. Let's see if I can clarify this a little bit. I had to shade to the right of this guy and to the left of this guy. So I know we're in between these two. But I had to shade above this one and below this one. So we had to be in between those two. Oh, you know where it is. Yeah, that's our shady bit. So this is the region with all of our solutions. And if you turn it on its side, it kind of resembles a trapezoid. It's got that trapezoidy feeling going on. Yes, it does. Yes, it does. So let's use our lovely little shaded chunk here to answer some more questions. So about how much would Miguel expect to spend if he purchases eyeglasses that are regularly priced at $320? Go ahead and hit pause, use the graph to help you out, and then hit play when you're ready to check your work. All right, so if Miguel's spending $320, I'm gonna use my pen here. If he's spending $320, he could spend anywhere from here to here, right? Oh, sorry, not my best. So somewhere in between here, this is kind of our region. So that means he could spend as little as $80, or he could spend pretty close to 130 bucks. So Miguel should expect to spend between $80 and $130 if he's purchasing glasses that are regularly priced at $320. So Miguel is looking at this, and Miguel is definitely going to purchase a pair of eyeglasses that are on sale. Good call, Miguel. What is the least amount of money Miguel can expect to spend, and what's the greatest amount he can expect to spend? Go ahead and, again, use the graph to help you out, and then hit play to hit pause and work it out, and hit play when you're ready to check your work. All right, well, if he goes on the cheap end, all right, so he's going for that $120 pair, it looks like on sale, the least he could expect to spend is $30. Fair enough. So the least amount of money Miguel can expect to spend is $30 if he purchases eyeglasses that are regularly priced at $120. But he could go high end here, right? He could go all the way up to those $360 sale glasses, which means he could end up doing $360 and he's only 25. It's only 60% off at 75, in which case that puts him on the top end out here. So it looks like he could be spending as much as $140. So the greatest amount of money Miguel can expect to spend is a little more than $140 if he purchases eyeglasses that are regularly priced at $360. So Miguel's been looking around, he's checking it out, and Miguel decides on a pair of eyeglasses that are regularly priced at $240. All right. So I've got a few questions to go along. So Miguel's now made his decision. We're going with $240. I've got two questions for you. Part A, can Miguel expect to save more or less than $140 off the purchase price of this pair of eyeglasses? And again, you can totally use your graph to help you determine an approximate answer. And part B says to use algebra to determine the greatest amount of money Miguel can save by purchasing eyeglasses that are regularly priced at $240. So use the graph for part A, but use some actual algebra and do some actual math for part B. Go ahead and hit pause to work these out and then hit play when you're ready to check your work. So using our lovely graph here, we've decided at 240. So here's the lowest, which looks like it's about $60. And here's the highest, which doesn't quite get to 100. That looks like what, 96-ish dollars? So according to the graph, Miguel can expect to spend between $60 and $96 for eyeglasses that are regularly priced at $240. Well, that means he's going to be saving more than $140, right? So that savings is somewhere between $144 and $180. That's more than 140 bucks. Good job, Miguel. And again, it said to use algebra to actually determine it. Okay, so let's see if we can figure out the greatest amount he can get off. Remember we said that S had to be less than or equal to, what was that? 0.0. Naughty Miss Scott. I know. Hang on. I'm going to fix it. We're going to do a little bit of math here. We're going to substitute in because, of course, the best deal is getting that 75% off. So fine then. That was a whole less than, S is less than 0.25 R. And we're seeing that R is 240. So I'm going to plug in that 240. And then I'm going to grab a calculator. 240 times 0.25 means that Miguel would be spending, and actually I did this wrong. We want to know how much he's saving, not how much he's spending. Hang on. I can fix it all. There we go. So we want to know how much he's saving. And of course, he can save as much as 75%. So 0.75 times R. So we'll plug in for R 0.75 times 240. I knew I was doing something funky. So 240 times 0.75 means Miguel could save, the greatest amount Miguel could save here is $180. Sorry, having issues. So yeah, I can substitute in the value of R as 240 in the greater discount and then just solve it. And yeah, Miguel could save $180. Good job, Miguel. One last activity, and then we have a short talk the talk. So Jose interviewed for 2 different sales positions at competing companies. Reliable Robotics has offered Jose a salary of $31,200 per year plus a 9% commission on his total sales. Robot Renegades will offer him $26,000 per year, which is less, plus a 15% commission on his total sales. So he gets more in commission, but less in salary with Robot Renegades. So Jose isn't sure which offer to accept. He's really great at making a sale, but he's just not sure which job will be better in terms of his pay. He is confident, however, because again, he's good at making sales. He is confident that he can make at least $2,000 worth of sales each week. So again, you're not actually going to write an email. You're going to write it down below here on your paper. Write to Jose with your recommendation of which job offers better compensation and provide evidence in your response, just like we were doing before. Go ahead and hit pause to work this out and then hit play when you're ready to check your work. So again, I am starting us off with a sentence equation for each one of these. So Reliable Robotics, they're saying that he's going to get $31,200 per year in salary plus 9% commission. So that's 0.09 times X. But of course, we have the competitors. We've got others here. So Robot Renegades is going to offer him $26,000 per year plus 15% commission on sales. So again, he gets a better commission, but a less salary. So let's actually work this out. Oh, $2,000 per week. Miss Scott needs to read her own directions. $2,000 per week. There's 52 weeks in a year. Hang on. I wrote that down wrong. I wrote this down wrong. I can fix it though pretty quick. Watch how quickly I can fix it. Do you want to see how quickly I can fix it? I can fix it fast. So I've got skills. Of course, only if I can make my pen work. Haha. I can make my pen work. So it's 52 times that 0.09x because there's 52 weeks a year, and 52 times 0.15x. Sorry about that. I should write things down correctly. It works better that way. All right. So we have it. I used an S here instead of X's, but you get the idea. You know how we're going to do this, just like we did last time. Since Y equals this guy, I know everywhere I see a Y, I can replace it with all of this. We'll substitute in. I'm going to get rid of those parentheses first. I'm going to multiply 52 times this guy and 52 times that guy. That's why I love my calculator. I don't like that I have S's on both sides. So I'm going to subtract that 4.68S from both sides. When I do that, 7.8S minus 4.68S gives me 3.12S. And of course, I'm going to subtract 26,000 on both sides as well, which leaves me with 5,200. And then we'll just grab a calculator and divide. Now, please remember that this is money. This is money. So when I do my work, I am going to round it to 2 digits behind the decimal when I divide for my final answer. So it looks like so you can use $1,666.67 in sales is the break-even point. So since this is the break-even point, this means that after this point, he's not going to make as much money with that first company, right? Because they don't pay as much in commission. Whereas with the second company, while there is a lower salary, if he makes more money than this, he's going to be getting more in his commission on his sales. So if Jose sells more than $1,666.67 each week, he should choose the job with Robot Renegades. But if he's selling less than that, then that's when he's going to go with the reliable robotics. Yeah. Oh, wait, Jose said that he felt pretty confident he could do $2,000 worth of sales, right? If he's doing $2,000 worth of sales, the second equation it shall be, he's going to make more than that, right? He's going to make more than this amount right here if he's doing $2,000 in sales. Time to go with Robot Renegades, dude. I'm just saying, that's the one. That's the one. All right, let's do one last bit. Cab time. The red cab company charges $3.50 upon entry and an additional $1.25 per mile driven. The yellow cab company charges $5 upon entry and an additional $1.15 per mile driven. So Emma's got to take a cab to the airport. Which company should she use if she wants to minimize the cost? Take a look at what we've been doing. You can figure this out. Go ahead and hit pause to work it out. Hit play to check your work. So I wrote 2 equations. I bet you're not shocked by this, right? $3.50 to get in the cab and $1.25 for the first cab company. $5 to get in the cab, only $1.15 per mile for the second cab company. And again, they're both equal to Y, so they should be equal to each other. Subtract 1.15x from both sides, leaves me 0.1x. Still have that $3.50, still have that $5. So I'm going to subtract $3.50 from both sides, and that gives me $1.50. But of course, I will divide that by 0.1, and I get x equals 15 miles. So If the number of miles to the airport is 15, the cost will be the same. So it doesn't matter which company she uses if it's 15 miles to the airport. If the number of miles to the airport is less than 15, she should be using the red cab company, right? They're cheaper to get in and they charge more per mile, but if it's under 15, she's actually going to save money. It'll be less expensive. If the number of miles to the airport is more than 15, that's when it's time to go with the yellow cab company because they charge more to get in, but they charge less per mile. It will be less expensive. So she needs to figure out how many miles it is to the airport. That's going to help her decide which company is better. As always, guys, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, click the magic Ask for Help button. It'll let me know. Come see me during office hours. I can help you then too. Don't be lost. Let me help you out. And I'll see you guys later. Bye.